Hello Saba, this is my live demonstration of the Simon Says game on the Zybo FPGA. So let's go ahead and program our device and let's play a little game. Let's see how many of these I can get right. Level 1, level 2, level 3. Ooh, I'm pretty good at this. Alright, one more. This one's gonna be tricky. I got it. I think it was this one. Oh, and I forgot the last sequence, but maybe it's this one? I got it wrong. So that's my incorrect input. To reset, you simply press button 0 and 3 and start again. I can do this all day. I got it wrong, never mind. So that's the live demo. I'll explain the code a little bit. So this game uses something called a state machine. And we have a couple state machines in this design. We have idle state, sequence generation, sequence display, user input, check input, incorrect input, correct input, and game over states. Now these states are responsible for managing the game's behavior and transitioning between different states based on the player's input and game's output. So let's go on idle state. Okay. So the game starts in idle, where it waits for the user to press a button to start the game. Once the user presses the button, the game transitions to the sequence generator state, where it generates a sequence of button presses that the user must repeat. Now in the sequence display state, the game displays the sequence of button presses to the user by lighting up the corresponding LEDs for each button press. The game then waits for the user to enter their guess, and the user input state, where the user has to enter their guess by pressing the buttons in the same order as the sequence displayed by the sequence display state. Next up, the game moves to the check input state, where it checks whether the user's guess matches the sequence generated in the sequence generator state. If the user guess is correct, the game transitions to the correct input state, where it indicates to the user that their guess was correct by flashing the LED. And if I had speakers, I would also display a sound, but I don't got speakers. It's an interesting project though. The game then increments the level counter and transitions back to the sequence generator state to generate a new sequence of button presses for the user to repeat. Now, if the user guess is incorrect, the game transitions to the incorrect input state, where it indicates to the user that their guess was incorrect by flashing the red LED, and then the game transitions back to the sequence display state to once again display the sequence of button presses again. Finally, the game enters the game over state, which indicates to the user that the game is over by flashing the LEDs. And the game then transitions back to the idle state to wait for the user to start again by pressing, reset, and keep on playing. Overall, this state machine controls the flow of the Simon game, manages the game state, and interacts with the player using LEDs and buttons. It was a great example of how VHDL code can be used to create games and simulations. Thanks for watching, and I'll see you in the next one.